Hey guys, welcome to my new tutorial. A few days ago I posted this work on Facebook page. Some of you guys were interested to get the project file. So today I decided to post the project file on Gumroad, which is free, and also record a quick tutorial. So let's go. Okay guys, so here is the project file on Gumroad. Please check out the description for the link. Okay, now we are in the Houdini. This is the project file which you will find in the Gumroad. Here is our particle advection simulation, and let's start it from scratch. Okay, first we will choose a geometry node. Let's call it something like particle advection. First we should make our source to our Pyro simulation. We can start from a simple sphere. Okay, let's change it to a polygonal. Let's scale it down, something like this. Let's add the normals. Let's add a transform and move it up a bit, like 1 unit. Yeah. And now let's add a fluid source, which will take our sphere and turn it into a smoke. Okay. We don't have to change anything here, but later you can add some curl noise to your velocity volume to give some interesting look. Okay, we are almost ready with our Pyro source. Now let's add a null. Let's call it Pyro source out. Okay, now let's make the Pyro simulation itself. Let's choose a DOP network. Let's call it Pyro sim. Okay, let's double click, go inside. And for the basic smoke simulation, we'll need our basic 3 components. First is Pyro solver, and second is our smoke object, and we need our source volume. Now in this source volume, on the volume path, we should point to our null, Pyro source out, which is this null which we made. First let's make our container size a bit bigger. Let's add few subdivisions, like 0.5 is okay. Let's play and see what we get. We get our source volume here, but it happened nothing. So we have to change few settings here. Okay, first thing that we have to change here is the temperature volume. We don't have a temperature here, so we have to change the temperature to a density. It will make our smoke to rise up. Let's see. Okay, let's go to the Pyro solver and check this combustion and shape settings. Okay, so let's see. Okay, we have to add our velocity and see what we get. Okay, so if you notice now, the smoke is going off this container. We need to make it to collide with container, and for that let's go to our smoke object and check these close boundaries. And now it will collide with walls. And now we see the smoke rises up and hits the top of our container. But for this case, we will reverse the effect, so it goes down, not up. For that, we need to change the scale temperature to a -1. And let's play and see. Okay, now it hits to the floor and makes this nice shockwave effect. I think we need to make our container size a bit bigger, because you see it cuts off the edges just a bit. Okay, we set our Pyro source, we made our Pyro simulation. Now let's move on to the particles. First we need to scatter some points. Let's choose a scatter node. Let's scatter some points on our fluid source. Okay, on the scatter node we need to uncheck these relax iterations. It will make the points more random. Now we need our pop network, our particle simulation. Let's choose a pop network. Let's connect our scatter to our first input. Okay. And we have our particle simulation. Of course, nothing will happen now. Now after our pop source, let's add the Advect by volumes node. Now for the particles to get advected by volume, in this source parameter we need to fit the velocity from our Pyro simulation. We can find our velocity field in this smoke object. If you middle click, we are on the first frame, it will not show us. If we go after first frame and middle click again on smoke object, we will see that we have pressure, velocity, temperature and density. Okay, how we fit this velocity into our particle advection node? The one way that I learned from some tutorial, which I will link below, is to choose a Pyro, no, not Pyro, it was DOP import fields. Okay, for the DOP network parameter we can track our Pyro simulation, or we can point it from here. And for the default object we need to write the name of our smoke object, and we can find our smoke object here, and let's copy the name and let's paste it here. Okay, now let's add a field by clicking this plus sign, and let's write vel, which stands for velocity. Velocity isn't smoke, so let's choose invisible. So now if we middle click on our DOP import field, we will see that we have velocity x, y and z. Let's choose a null object. Let's rename it velocity out. Let's go to our popnet. Let's choose our pop advection node, and for the sub parameter let's find and point to our velocity out node. Okay, and let's change the advection type to update velocity. Now if we play, it happens nothing because we have to change few settings from our source, particle source. First let's change the emission tab to all points. Let's check off this guide. Okay, now we see that particles are emitting on each frame. If we go one frame in and check our pop source, we have 2000 points here. If we move like on the 24th second, we have 24,000. So we say that particles are emitting on each frame. For this case, we need them to only emit on the first frame. So let's go to the birth tab. The one way we can keyframe this impulse activation. We can set a keyframe on the first frame, go to the second and change it to 0. And alt click. Oops, it's always 0. On the first frame, let's change it to 1. Okay. Okay, now we see that it emits only on the first frame. Also, there is a way we can do it with expression without a keyframe. We can type $FF, which means the simulation frame is smaller than 2. So basically it means that it will emit particles only before this number. So now it's emitting only on the first frame. Okay, so we have the same result as with keyframe. Okay, now let's go back to our scatter node and add more points. And let's see how it looks. Now in the pop advect node, let's change the velocity blend to 1. So now it will fully follow our Pyro simulation. Let's see. Okay, it looks much better. I think we can add a few more points, like one more 0 here. And let's see how it looks. I think it looks nice. Let's check it. Let's view it from top angle. We get this nice shockwave look from top view. So in my particle advection video, these all are top views. Now this is the same simulation but from top angle. This is something that we have now. Again, top view, top view. This one is the side angle as we have now, but with a negative value. So let's see how we can get this kind of look. Okay, now if I put to -1, I get this weird effect. I don't know why, it looks a bit different. Yeah, it's kind of interesting. I guess because we have a different setup that we have, you know, we don't have exact the height from sphere to the floor. Maybe I don't know what exactly is the issue that we get different result than here. Let me quickly open up the project file which I shared on Gamrod and let's see what we'll get there with a negative value. Okay, now this simulation which you will find on Gamrod setup. Okay, let's go to our PopNet. We have our particle simulation. You see it's a bit different. Okay, now let's change this particle advect node to a -1 and see what we get. Okay, now we see that we have something very similar to this effect. Okay, now we have our setup. Let's move to our rendering. Let's set up a camera. Let's find some nice angle. Something like this. Now for the rendering we have to make two things. We have to define the particle size and the particle color. This technique I learned from Steven Nipping, which I highly recommend to check his Particle Fundamentals 1. I will link the tutorial in the link below. Okay, now let's choose a VOP attribute. We don't need this two. Let's make a parameter. This parameter, let's call something like particle scale and the label particle scale. Okay. Now to export this parameter, we need a bind export. Let's connect our particle scale to an input, and the name, let's call it, we have to call it like p scale. It will recognize the p scale parameter, which stays for particle scale. Okay, now if we scroll down, you will see that on the attribute VOP, which let's call particle scale, we have this particle scale parameter, which is 0 now. Let's call it something like 0.01. And now let's add a material to our particles. Let's go to our material palette and let's scroll down until we'll see it was called constant. Let's drag this constant material here. Now let's go back to our main folder. I don't know if it's right to call it folder or not. So let's go to the render tab. Let's choose the material. material constant. This constant material doesn't have any shadow and lighting information, which renders really fast. Okay, now let's render and see what we get. And let's go to render view, camera 2, and let's hit render. And let's see what we get. We get nothing. Okay, I forgot to put this flag on. Okay, let's render now. We have this big ball. Let's scale down our particles. Let's make it even smaller. No, not bigger, smaller. And now let's define the color of particles. Let's choose one more attribute swap. Let's call this one, let's tap the rendering, let's call this one particle color. Okay, now we need a ramp node to define the colors, ramp, and we need to, the way I do it now, but I think it's not the right way to do it. Maybe I'm sure there is a better way to do it, but for now let's have this divide node. And the way I did yesterday, I tried to divide the position of particles by velocity. Let's connect to a ramp node, and our ramp node let's connect to a CD, which is the color. Let's see what it does. Let's hit render. And let's change the colors, like something like bluish, and another one like something like pink. And also for now let's scale a bit up the particle size. Let's see if we can get better colors, like this one, maybe this one, too dark. And the other one, maybe we can change it to red, maybe a lighter red. Let's try to reverse the colors and see if it looks any better. Okay, I think this looks more interesting. I think we can scale it up to 0.05. Okay guys, we are almost ready with our effect. Okay, you see this looks nice. Now I will jump into a fusion where I will show you how to add some basic color correction and some glow. Okay guys, we are back. We are in a fusion. Let's play our sequence and see. Okay, first what I did in my video, I added some color correction and I did some gain to make the colors stand out more. Okay. And what I used for glow, I used this exponential glow, which doesn't come with Fusion. It's not a Fusion default plugin. I learned about it from Rich Not 40. I hope I pronounced his surname correctly. By the way, if you're looking for get into a Fusion, Rich have a very good introduction to multipass compositing in Fusion. And he also talks about this glow effect. This, I forgot the name, is called this exponential glow, which you have the link in the description. This tutorial and also the link I will include in the description. Okay, so find the exponential glow, the link. Now we have to find setting and macros. And in this list we have to look for exponential glow. Exponential glow. Maybe I missed it already. Let's Control F to search. Exponential glow. Let's click it. It will give this code. Let's Control A, Control C to copy and Control V to paste here. It's a really nice glow compared to the standard glow effect. Okay, let's add this glow effect. Usually I like to keep the radius for the particles glow low. Okay, and add some fall off, reduce the fall off. Let's play it, see how it looks. Oh, yes, I think it looks nice. And on top here we have the sequence rendered from this HIP file which is on Gamrot. So if you get the Gamrot project file and render it directly, you will get this result. Let's see how it looks with the exponential glow. Let's play it and see. We can keyframe the glow to have less glow at the beginning and stronger when the particles are expanding. Okay guys, I hope you found this useful. Please go and check the description under this video, in which I will link the project file, the tutorials which I mentioned. Thanks for watching and see you next time.